this is Siddharth, and today I will be explaining you depth first search solution approach to solve Sudoku problems. I'm currently pursuing knowledge engineering at NUS ISS, and before this I was working as a software engineer at Vassar Labs. A classical Sudoku consists of 9 rows and 9 cells, 9 columns, in which some of the cells are left blank. The player of the game must fill in values between 1 to 9 in such a way that the value is unique across the column and across the corresponding row and a small 3x3 grid. The game is completed when the player is able to fill in all the blank values. Search problems are a typical class of problems in which our goal is to find an object X that is satisfying particular constraints. A typical search problem that you might encounter in everyday life would be you trying to find the name of the person in the telephone directory to call to. Depth first search solution approaches are a family of solution to search problems which are exhaustive in nature. They are exhaustive in a sense that we iterate through each possible item in the search space, and if we find the item that satisfies the required constraints, we return that item. Depth first search to a typical chess would involve iterating through each possible moves for a given instance of chessboard. This is a pseudo algorithm to the DFS. For a typical DFS, we start with one of the vertices and we mark it as visited. We continue our DFS by visiting its corresponding child nodes. In this case, we continue by visiting its child node 2. We mark this child node as visited, and this process continues over by visiting its child node. The DFS stops here when all the child nodes are visited and all the nodes are marked as visited. So DFS in Sudoku. Simply put, using DFS in Sudoku means iterating through all the possible grids and finding the grids which satisfies all the constraints. Here's a pseudocode for a DFS approach to solve Sudokus. We start by finding a particular cell. For that particular cell, we iterate through all the possibilities, and for each possibilities we create a new puzzle prime. If this puzzle prime is valid and complete, we return this puzzle, else we continue guessing. This process makes sure that all the possible solutions are explored, and the solution which is valid and complete is returned. So what's the practical worth of a DFS? This is a problem that we came across during my workspace at Vassar Labs. The problem is we want to calculate the inflow value at Prakasam Barrage. Prakasam Barrage is a big reservoir in the Indian state of Arunachal Pradesh. So this problem can be modeled by saying that Prakasam Barrage consists of some child locations, and these child locations have some child rivulets with some flow values. To calculate the flow value at Prakasam Barrage, we have to sum all the flow values present. So by using a DFS approach, we iterate through each of the leaf nodes and we sum all the flow values to get the total inflow sum at the Prakasam Barrage. So why are we bothering finding the inflow values? What's the business value to the solution? Given the instantaneous flow at the child rivulets and travel time to Prakasam, we can predict the inflow to Prakasam Barrage at a certain instant. So this helps government to decide whether to step up, step down, or stop the inflow to the barrage to balance between the utilization and to avoid flooding. So here's the references and the links that I've used. You can download the code from my GitHub repository. I will quickly go through the code demonstration here. So this is a typical Sudoku file that has to be fed into the code. This is a DFS implementation in Java. So as I mentioned, we iterate through each possibilities, and for each possibilities we try to solve that Sudoku. If the Sudoku is valid, then we return that Sudoku, else we continue with our process. So you can run this code by putting in the file name as the command line param. So the problems, this is the problem Sudoku, and this is the solution that my Sudoku solver gave. It's given it's just a 9x9 Sudoku, the solution comes in quite fast. So thank you everyone. Hope you understood the DFS and enjoyed the video. Thanks for tuning in. Bye.